Welcome back to Maths with Mrs. J. I wanted to start talking about trigonometric identities. And in particular, I wanted to introduce to you what is known as the Pythagorean identity. Before we talk about that, I just want to clear up a difference between an identity and an equation. An identity is something that will work for all values of theta or x. Okay, an example as a normal equation involving x would be something like 2x plus 4 equals 2x plus 2. That's an identity that works for all values of x. However, if it only works for certain values of x or certain values of theta, so if I said 2x plus 4 equals 9, then obviously that's an equation because it only works some of the time. Sometimes you'll have an equation to solve for which there is no real solution. That's okay as well. Now, what we're dealing with here, I've just drawn the first quadrant because that's what we're focusing on here. Remember that sine of theta is your y value, which is b. Cos of theta is your x value, which is a. Because this is a unit circle, the hypotenuse is 1. So we know that a squared plus b squared is 1 squared because of Pythagoras' theorem. So subbing in, doesn't matter whether you say cos squared plus sine squared is 1 or sine squared plus cos squared is 1. Either way, both of those trig ratios squared equals 1 as long as the angle is the same. It doesn't matter what that angle is. It could be the most complicated expression in the world. As long as it is the same, then sine squared plus cos squared is 1. You need to know and be familiar with this Pythagorean identity. It will be used quite a bit in your identity proofs. An example of that, let me just show you here. If we look at question 1, I've got sine squared of this expression plus cos squared of this same expression. Doesn't matter how complicated the expression is, this is in the form sine squared theta plus cos squared theta, so the answer is just 1. Nice and easy. Okay, rather than learning this formula in lots of different versions, just be able to manipulate it. If I have 1 minus cos squared something, according to this, I'm going to get sine squared of whatever that angle was. If I have the square root of 1 minus sine squared, well, that'll be the square root of 1 minus sine squared is cos squared. So we're going to get cos. If we had plus or minus here, we get plus or minus. Let's just do this expansion here. Let me just get rid of this stuff here. It's in our way. Okay, so just bear in mind, remember that if we had an a plus b squared, we get a squared plus 2ab plus b squared. So when we do this, we're going to get sine squared plus 2 sine theta cos theta. I just went and erased stuff from there and then I went and added more stuff. Sorry about that. Plus our cos squared theta. Just bear in mind when I say cos squared theta, what that means is cos of theta all squared. The reason we don't write it after the theta is that then there could be some confusion as to whether you're squaring the angle and then taking cos of it or whether you're taking cos of the angle and then squaring it. So we write it like that. Okay. What have we got here? Well, what we've actually got is we've got a sine squared theta plus a cos squared theta. What are they going to make when we put them together? They're going to make 1. And then we've just got this expression here. Now, for what it's worth, this expression here is another very common identity. This is always going to equal sine of 2 theta. So that might be one that you might like to remember. In our next video, I'm going to give you some of the main ones that you need to know, and then I'm going to teach you how to do an identity proof. It is very important the way you do an identity proof. You can't assume that it's equal in order to prove that it's equal. So I'll show you all about that in our next video.